Welcome to an example of classifications of functions such as one-one function, onto function, bijections, and invertible functions. In each of the following cases, state whether the function is one-one, onto, or bijective. Justify your answer. One part. F is defined from set of real numbers to real numbers given by f of x equal to 3 minus 4x. Here, domain and codomain both are given to be set of real numbers. And the rule by which you have to get the image is 3 minus 4x. You take any x here in the domain, its image will be 3 minus 4x. So image of 2 is 3 minus 4 into 2, 3 minus 8, that is minus 5. Image of 3 will be minus 5. So using this rule, the images are calculated. Now, let's see whether it is one-one function. What is one-one function? A function f defined from set A to set B is called one-one function or injective function if distinct elements have distinct images. Distinct elements, two different elements you take from here, their respective elements should be also distinct. That is, x1 and x2, if they are unequal, it should imply that their respective images are also unequal. These should also be unequal. Or in other words, in case the images happen to be equal, if the images are equal, in case the images happen to be equal, that must imply that the pre-images x1 and x2 should also be equal. These are two interpretations of this one-one function definition. Now let's check whether this function follows this definition. I'll go by the second interpretation. Let us take f of x1 be equal to f of x2 for some x1 and x2 of the domain. Let the images be equal. Two images, let them be equal. Now, what do we mean by f of x1? F of x1 must be 3 minus 4x1. F of x2 is 3 minus 4x2. So this equation can be rewritten as 3 minus 4x1 equal to 3 minus 4x2. Let's simplify further. Yes, this is simply a linear equation. This can imply that minus 4x1 equal to minus 4x2. Dividing by minus 4 on both sides, we have x1 equal to x2. Here, clearly, these two numbers equality clearly imply that the x1 and x2 must be equal. No other way. In case f of x1 and f of x2 are equal, then it is automatically following that x1 and x2 should also be equal. So this is very well fitting with the second interpretation of the definition. Hence we say the function is one-one function. Let's see whether it is an onto function. A function f defined from set A to set B is called onto function or surjective function f. For each element y that we take in set B that is a codomain, we should be able to get an x in the domain. There exists at least one x in the domain, such that the image of the x is the y itself. F of x is equal to y itself. Three stages we have to verify. Let me begin with one element taken in the codomain. Let y belong to the codomain if possible. Let y belong to the codomain. And if possible, let y be equal to 3 minus 4x. Let's take y, the element that we have taken. Suppose it is 3 minus 4x. From here, let's try to calculate what is x. It is possible to calculate, of course. Yes, y minus 3 divided by minus 4. That I am rewriting as 3 minus y upon 4. From this linear equation, solve for x. I could get an x. But now the question is it possible to have this x in the domain? There should exist at least one x in the domain. So whatever this y was, is it possible to be there in the domain? Let's check if y is a real number. 3 minus y surely be a real number. Any real number divided by 4 is also a real number. So this x that we have calculated will surely be a real number for any y that we take as a real number. If y is taken as a real number, 3 minus y upon 4 will also be a real number. But remember, in case our domain was set of natural numbers, we would have said at this stage, this 3 minus y upon 4 need not be a natural number, we would have said. Because division by 4, a real number divided by 4 need not be a natural number. There we would have stopped and said it is not onto, but here it's not happening so. 3 minus y upon 4, we need to get it in the real number. Yes, no problem. This is a real number. Now, this is the second stage only. For every y, we could get an x in the domain. But the third stage is more important. The x that we have calculated, will its image be equal to the y? Will the f of x be equal to y itself? Let's go ahead checking. F of x. Now, f of x, let's calculate. X is this, remember. So, f of x, how to calculate? The rule given to us is 3 minus 4x. So, f of x is 3 minus 4x. F of 3 minus y by 4 is equal to f of x. In place of x, you use this. So, we need to use this in this rule. Let me use it in this rule. So, it comes as 3 minus 4 into 3 minus y upon 4. 3 minus 4 into x. 3 minus 4 into x, in place of x, I am using this. And let me simplify further. Yes, here this 4 and 4 cancel. And we have the next step. 3 minus, in the bracket 3 minus y. That eventually gives me equal to y. So, the x that I have calculated, first of all, that is available in the domain. Secondly, the image of that x that I have calculated happens to be equal to y itself, which is what I wanted to have to call it an onto function. So very well, this explanation is matching with the definition of onto function. We took a y in the codomain and we calculated an x in the domain. And we proved that the image of x is equal to y. F of x is equal to y. We proved it also. Hence, we conclude this function is an onto function. Something more about it. A function which is 1, 1 and onto is called a bijection. So, this function is a bijection also. It is a bijective function. Also, a bijection is an invertible function always and has a unique inverse. This function is an invertible function and has a unique inverse. In each of the following cases, state whether the function is 1, 1, onto or bijective. A function f defined from set of real numbers to set of real numbers given by f of x is equal to 1 plus x square. This time also, both domain and codomain are given to be set of real numbers. And the rule given to us is f of x is equal to 1 plus x square, which means image of 2 is 1 plus 2 square. 1 plus 2 square is 1 plus 4, 5. So image of 2 is 5. Image of 0 is 1 plus 0 square. So image of 0 is 1, etc. We need to check whether it is a 1, 1 function. A function f defined from set A to set B is defined as 1, 1 function or injective function if distinct elements have distinct images. That is, whenever two numbers x1 and x2 are unequal, their images should also be unequal. In case the images happen to be equal, then the pre-images should also be equal. These are the two interpretations of this definition. Now, let's go by general element method to check whether it is one function. That is, I'm using the second interpretation. Let us take two numbers, two images f of x1 and f of x2 are equal for some x1 and x2 of the domain R. Let the two images be equal, which means f of x1, that is 1 plus x1 square, f of x2, that is 1 plus x2 square, let them be equal. This is an equation. This equation I solve further and check whether it would definitely imply this. Yes, go ahead. Here, next step, I'm writing simplify as x1 square minus x2 square equal to 0, as 1 and 1 both are equal on LHS and RHS. This quadratic equation I factorize using a plus b into a minus b factorization, x1 minus x2 into x1 plus x2 equal to 0. As the product of two factors is equal to 0, either of the factors could be equal to 0. Either this factor equal to 0 or that factor equal to 0. This one gives me x1 equal to x2 and the second one gives me x1 equal to minus x2. Now let's see the second case. Is it possible? Here, we are given set of real numbers and x1 and x2 are taken from set of real numbers. So one x1 and another x2, x2's negative can be equal to x1. There is no problem. Two numbers, opposite sign numbers, x2's negative can be a positive number equal to x1 or vice versa. So, in case this domain was given to be a set of natural numbers or only positive numbers, we would have said it's not possible. Because if x1 and x2 were natural numbers, in case they were natural numbers, a natural number's negative cannot be another natural number. So here we would have said it's not possible. But we have no reason to say so in this case. We have real numbers. There are negative and positive numbers also. So this is possible. Hence we see that whenever the two images are equal, it's not strictly implying this case, which is what we wanted. That is one of the cases. But there are other ways also the images could be equal. So whenever the images are equal, the pre-images must be equal. It is not being fulfilled. The second interpretation is not being fulfilled. Therefore, we conclude that the function is not one function. To establish this, we could have simply used a numerical example. That is, a counter example. Remember, to establish the invalid situation of a definition, we can use a numerical example. An example that goes against the definition. Here I take two numbers, 2 and minus 2, which are obviously unequal. These are the x1 and x2 that I have taken. The first interpretation I am going by. I take x1 and x2 as 2 and minus 2, which are obviously unequal. Now, what is the image of 2? And what is the image of minus 2? Let's calculate. Image of 2 is 1 plus 2 square, that is 5. Image of minus 2 is 1 plus minus 2 square. Minus 2 square also is 4, so 4 plus 1 is 5. Image of 2 and minus 2, both are equal. F of 2 and f of minus 2 are equal. So when we took two numbers unequal, it could not imply that the images are unequal. We are getting the images equal instead. So this numerical example goes against the definition. So we treat this numerical example as a counter example. And we conclude that the function is not one function. Not one function. Let's see whether it is an onto function. A function f defined from set A to set B is called onto function or surjective function if for each element that we take in the codomain, we should be able to find at least one x in the domain such that the image of that x is the y that we have taken here. Let me go by an example. Let y is equal to y belong to R in the codomain. I'm taking a y here. If possible, that y be written as 1 plus x square for some x. If it is written so, I'm calculating the x using this equation. Y minus 1 under the root will be x. Now x is possible to calculate, but we need to check whether the number that we get like this would belong to the domain. Here the domain is set of real numbers. For every real number, y minus 1 is real number, I agree. But in case this y minus 1 happen to be a negative number, say for example, if y is equal to minus 3, minus 3 minus 1 is minus 4 and its square root is the x. That x you will not be able to find in the set of real numbers because square root of minus 4 cannot be a real number. So the x that we have calculated here may not belong to the domain. It's not always possible. So we started by taking if possible let it be so. Now we have to realize that it may not be possible for many numbers as y. It goes against the definition. Second stage we could not fulfill. Therefore, we conclude that the function is not onto function. This proof could be established just by using a numerical example that goes against the definition. That is a counterexample. As we have already taken, I'm taking again minus 4 as the y. Take y as minus 4 from the codomain. Now look, for what value of x can be 1 plus x square equal to minus 4? X square is supposed to be a positive number. A positive number plus 1 can never be equal to minus 4. So this minus 4 will never be an image of any x. So we write that there is no x in the domain for which 1 plus x square could be minus 4, or in other words for which minus 4 could be the image. It's not possible. Hence we conclude that the function is not onto, as this numerical example goes as a counter example. A numerical example that goes against the definition, which counters the definition. So by counter example method, we have proved that the function is not an onto function, not an onto function.